Hi, my name is Sven Oehme. I'm DDN's Chief Research Officer. Today I'm talking about performance for AI success, how DDN's optimized data path generates repeatable and proven results in large-scale AI and machine learning deployments. DDN is the world's largest privately held storage company. Our enterprise division focuses primarily on traditional IT systems for virtualized environments, high-performance databases, as well as software-defined storage. Today's talk primarily focuses on products out of the at-scale division, which is focusing on AI storage systems, HPC storage at scale, and scalable data management solutions. DDN is the world's leading provider of accelerated data solutions. We have 20 years of technology leadership, more than 10,000 customers across market segments, more than 1,000 employees in over 20 facilities, 10 technology centers around the world, own 150 patents, and have sustained multi-year growth and profitability. During this presentation, I want to show you why we call ourselves proudly the world's fastest HPC and AI storage at scale, how we leveraged our 20 years of leadership HPC experience, deployment of some of the largest storage systems in the world with some of the most challenging requirements. I will share how we delivered world-class performance combined with effortless growth in reliable, resilient, and flexible solutions. So if your applications are constrained by storage that doesn't scale, does not use optimized protocols required for high-performance analytics, and can't effectively move data to your workloads, then we have the proper solution for you. And we'll explain that in more detail over the course of this presentation. In our proven solutions, we leverage independent scalable building blocks. The AI 200X is an all NVMe flash array delivering over 20 gigabytes per second throughput. The AI 400X is a hybrid system that, beyond doubling the throughput and IOPS performance of the 200X, also allows the attachment of HDD capacity, which is very successful combined with our software tiering capabilities. I'm going to explain in more details later. The AI 7990X building block is primarily for cost-optimized large capacity deployments. Each of these building blocks can be mixed and matched to build a custom solution to meet every demand in capacity or performance. The key to our solutions is our Exascaler software stack. Exascaler delivers maximum performance and combines the individual hardware building blocks into one scalable namespace that can be integrated and support any workflow at any scale. Our Exascaler solutions are deployed in very large-scale systems, several exceeding 100 petabytes in a single file system namespace for massive scale. Our stratagem tiering capabilities allow you to leverage flash and HDD at the same time, while our software handles the proper placement of the data based on either I/O patterns, size, or frequency of access. We can deliver a secure multi-tenant solution by virtually partition the capacity of a single Exascaler system amongst the individual tenants and give each one secure access to their own data. Not every device or sensor can run and connect to our storage system using a high-performance POSIX client. Therefore, our Exascaler data services support allows seamless integration into the Windows world via SMB, the Unix world via NFS, and the IoT world via our S3 compatible object interface. This allows sensor to directly upload data via S3 into the Exascaler system, so you can run analytics immediately on it using the POSIX client, which is significantly higher performing. DDN plans to support GPU direct storage, which we are working actively with the NVIDIA engineering team to deliver in a future software release. DDN Exascaler combined with DDN Insights delivers real-time analytics capabilities, allowing you to break down of individual storage requirements, latency, as well as bandwidth consumption of individual jobs or projects within an Exascaler system. It also allows you to identify inefficiencies on a particular job and also can be used to charge back to your end user base. The first data path optimization I would like to introduce you to is our Stratagem hot pool support. Stratagem hot pool support allows you to combine flash capacity with HDD capacity, for example using an AI 400X with some flash and some disk capacity attached to it. And the software stack is leveraging the I/O patterns, the size of the data that you're storing, as well as the temperature of frequent access data to decide if the data should be only initially stored in flash and later pushed to HDD, or remain in the flash tier for faster subsequent access based on the patterns that we see you accessing your data. This allowed one of our finance customers to have a 5-time improvement for SaaS and Informatica runtimes, as well as other financial risk analytics tools, leveraging our technology at a smaller footprint and lower support cost compared to the previous product that they were using. While in the past, traditionally throughput was one of the biggest challenges for analytic systems, workloads tend to become much smaller in size and significantly more metadata heavy these days. So what we demonstrated with our current AI 400 products is that we can sustain up to 4.8 million random read IOs per second to a single DGX A100. This is more than 40 times of what we get reported from customers, what they're able to achieve from their existing traditional NFS storage, and therefore gives you significantly more headroom to drive some of the most demanding workloads in your analytics system. This is in part enabled by our multi-rail capabilities in the system, where each individual client can use multiple parallel connections, one per individual network adapter, to reach one or multiple storage devices out in the fabric. And with this significant high parallel access is how we achieve these massive scalable numbers. This extremely high scalable random I/O performance, combined with similar scalable metadata performance, where we can, by adding individual AI 400 building blocks to the system, linearly scale the performance of metadata of the system. This enables the support of the most demanding small file and millions or billions of files workloads in your analytics solution. Highly scalable metadata performance combined with small file random I/O performance is key to support deep learning applications leveraging PyTorch as an example, as seen on the screen here, to linearly scale the workload with the number of GPUs you leverage in an individual job to run an experiment. As you can see, while traditional storage leveraging NFS is essentially limited in its scale after a very, very small number of GPUs used, you can see on the right, by leveraging AI 400X systems, we can show absolutely linear scale from one to multiple GPUs, and you simply extend multiple building blocks to get to whatever scale you needed to scale. This massive scalability and performance capabilities are used by our customers like Recursion, who were able to speed up identification of potential life-saving molecules to develop new treatments by a factor of 50. They were able to reduce the time to insight from years to weeks. As I mentioned at the beginning, we are collaborating with NVIDIA Engineering to potentially add support for more advanced data transfer capabilities into our systems. GPU Direct Storage is one of those interfaces. It allows us to move data leveraging high-performance network interconnects very efficiently between the storage hardware and the GPU memory. By bypassing CPU and the otherwise used memory bounce buffers in the host, we can significantly reduce latency by up to almost 4x, increase bandwidth by up to 8x for given workloads, and reduce CPU load on the host, which now can be leveraged for other critical tasks. I also mentioned briefly our multi-rail network simplification and capabilities we have in our software stack. Enhanced multi-rail can manage multiple client network interfaces on a single network. It automatically detects the network's interfaces on the client, and it efficiently balances the traffic between all the available network links. It is resilient, can automatically detect failures on links, and dynamically fail over and recover from link failures. It is also completely hardware aware and understands the topology of the system in order to use the most efficient way to get data from a request in the client to or from the remote storage system on the other end of the network. It allows highly parallelized transfer of data and enables very fast, simple deployment and management with the tools provided by Exascaler. This supports the extremely high I/O capabilities that we've demonstrated before by improving peak performance through a single mount point provided at the client, through multiple network interfaces at the same time, and it supports Ethernet as well as InfiniBand networks. Multi-rail doesn't only help with IOPS. It also allows a significant improved scalability in terms of bandwidth. As you can see here on the chart, where traditional NFS solutions max out at a few gigabytes per second, with our multi-rail capabilities, even by not using GPU direct storage, the more advanced potential future interface, we can get 99 gigabytes per second throughput from a single DGX client and only leverage 23% of CPU load on the machine. With this massively proven scalable capabilities of our storage stack, we can demonstrate full I/O saturation with an A100 GPU system, going from one GPU at 24 gigabytes per second all the way to almost 180 gigabytes per second in the system. This allows you to deliver fastest time to insight for the most demanding applications, workloads, and data types. NVIDIA is not a very good, strong technology partner. It's also a large customer of ours. The latest announcement of the NVIDIA Selene SuperPod is leveraging DDN storage internally to power that system. We delivered 40 DDN AI 400X appliances that deliver a combined throughput of over 2 terabytes per second and over 120 million IOPS. It's a fully integrated and optimized storage system for DGX A100 systems, can be rapidly deployed and delivers very predictable phased scaling. In the Selene SuperPod, 40 DDN AI 400X appliances support 280 NVIDIA DGX A100 systems connected over an HDR200 InfiniBand storage network to deliver these performance capabilities. To make it easier for our customers to build proven, tested, qualified solutions, we created multiple reference architectures that can be accessed by clicking the links on the documents on the page. Thank you very much for listening. And please reach out to DDN for your next AI or machine learning project. We are more than happy to assist you for finding the right solution for you. Thank you.